Hello, and welcome to Manitowoc ICE's webcast for April. Glad you could join me today. It's good to have you along, and we're going to run things a little bit differently again today. We're going to step it up another notch, if that's even possible, and we're going to do a little bit more hands-on. I always like doing the Flaker Nugget webcast. A lot of people ask me questions about Flaker Nuggets, so I want to get you kind of familiar with Flaker and Nugget ice machines today, and we'll pull them apart a little bit so you can see what's going on with them. So my name's Jonathan here at Manitowoc Ice. I'm an instructor here in Manitowoc, Wisconsin, and I'll be taking you through today's webcast. It's about an hour long. It may go over a little bit today because we're going to do a lot of live stuff. So maybe consider it might go a little bit longer, but I'll try and keep it as close as I can to an hour today. And we're reviewing RFF, RNF series Flakers and Nugget ice machines. And then we'll also take a look at a countertop nugget dispenser, which is also very similar setup in evaporator modes. And we'll look at those. I'm going to try and concentrate on the mechanics of it and less on the electrical side on it a little bit, just because of time permits. But we will still take a look at electrical on it. So at the end of today's webcast, there'll be a chance for you to demonstrate your amazing learning skills that you get out of this webcast. So there'll be a QR code later that comes up, and you'll be able to go there and take a quiz, just a short quiz, and then you can get to submit it with your email, and we'll send you a certificate of completion for this webcast, and we'll also send you a copy of the presentation as well. All right, so let's see. We're going to go over RNF and RFF Flakers and Nuggets. Here's a model number. This one happens to be a UFF. The U stands for under counter. We do have under counter Flakers, and this one happens to be a UFF 0200A. The F stands for Flaker. The first F stands for Flaker. The second F stands for refrigerant type. So you can see this is an F, which is for 404A. Think of the F as for 404A, and a T would be like for 410A refrigerant on it. This one makes 200 pounds a day, air cooled, as you can see, and this one happens to be 161, 115 volts. So 1 for 115, 6 for 60 hertz, 1 for single phase on this ice machine. Here's a look at some of those under counters, UFF, UNF. And remember that second letter designates whether it's a flaker or a nugget, okay? So UN is for a nugget, UF is for a flaked ice machine. I'm sure most of you technicians are familiar with the difference between flake and nugget. Flake is like a snowy ice, really good for seafood displays, salad displays, and you know, something it's used for as well as physical therapy. It's really good to pack a joint with the flaked ice. A lot of physical therapy places, a lot of high schools use it in their locker rooms too, to pack joints on athletes as well in their units. So UNF, UFF, nuggets, people love that nugget ice. It's real chewable, and that makes people really like it. And I even hear sometimes from even, I shouldn't say just ladies, but people trying to lose weight, they'll chew that nugget ice because they feel like they're eating something, but it has 0 calories in it. So there is a lot of stores now that all they'll accept is nugget ice, and they won't even have cubers in their stores anymore for soda. Places like Chick-fil-A, places like Sonic, you know, all they'll do is nugget ice. That's it. They won't do any cubers anymore. So they're definitely out there. And if you work refrigeration enough on ice machines, you're going to run into one definitely at some point. I get a lot of questions on them. The Z indicator on there at the end there, that indicates that this is a bare lead with no plug on it. So maybe this is a 251, maybe it's going to UK with 50 hertz, 230 volts, something like that, if you were interested why it had a Z on the end of that one. So RFF, RNF, Flaker Nuggets, very similar on how they operate, very similar. So They're very close. That's why we always kind of package Flaker and Nuggets together when we're talking about them. So there's a various list of models, everything from a little 300 all the way up to a 2,300 pounder on those ice machines. Now, something with Flaker and Nuggets that is unique is you want to use a special kind of cleaner. And this is the metal safe cleaner. I'm going to have Will zoom in just a little bit for me on the cleaner type. So they don't use the regular, thank you, Will. They don't use the regular Manitowoc ice machine cleaner descaler. They use the special metal safe cleaner descaler because some flaked and nugget evaporators are made of a different material that the regular cleaner is too strong for. Most of them nowadays, I would say about 80–90% are all stainless steel evaporators, but there are some still out there that used a different material evaporator that it was too strong for. And you don't really know what kind of evaporator material it is unless you pull the evaporator apart, and you don't want to have to do that just to see what kind of cleaner you're looking for. So we use metal safe on all Flaker and Nugget ice machines. Thanks for zooming in on that, Will. We'll go back to the presentation just a little bit. Thank you. So just to review, we talked about so far a little bit of model number identification, just to get you familiar with it a little bit. Self-storage under counter units. So those are units that have a bin built into them, and we call those self-storage a lot. And then modular. Modular is where we sell an ice machine without storage means. So it might be going on top of a bin. If it's a really big flaker, it could even be going on the top of a walk-in with a hole cut in the roof of the walk-in and just raining flakes in there for a really big seafood store. I've seen a lot of those before. A modular could be going on a soda dispenser. Now, there is no soda dispenser that likes to dispense flaked ice. They won't do it. But nugget ice, soda dispensers will dispense nugget ice, but they normally need a kit in them that sometimes people forget to convert them to nugget ice. You can't just take a soda dispenser that's pumping out cubes, throw a nugget machine on there and expect it to work. They need a different kind of agitator, and sometimes they need a level management kit on them to change the ice level in them. So check with your soda dispenser manufacturer, whether it's Lancer or one of our Servans or Cornelius. Check with them to see if they need a nugget conversion kit. That's very important when you put one on top of a soda dispenser. You can't just throw one on top of there. All right, so we're going to take a look at a Flaker evaporator unit here in just a second. And I'm going to go through pulling it apart on the Flaker evaporator. So I'm going to get up from my seat and I'm going to come around, and Will's going to work the camera for me so we can show you it taking it apart a little bit better. Thanks to Will, by the way, for being on the camera and doing about 25 things in the background. So I've got both a flaked ice machine and a nugget ice machine here, and I've taken them out of the unit, okay? Now, you don't have to do that to service them, but I've taken them out the unit to work on them, and just so you can see it better. But don't think you've got to suck the refrigerant out and cut the tubes to do this kind of stuff. They can be rebuilt without it. So the first one I'm going to do is this flaked ice machine right here. So I'm going to be undoing a few bolts here, so be patient with me as I take it apart. Now, why would you do this? Why would you take it apart in the first place? I mean, more than likely because you've got complaints about bearing noises. People are saying it's squealing really loud, it's making a really loud noise, and you want to go ahead and you want to look on the inside of the evaporator and you want to see what those bearings look like on it, see if there's any damage in there or any damage to the auger. So we'll take it apart, okay? So I've got 4 bolts on the top. I already got 2 of them loose, and I'm going to undo the other ones. Now, these are all metric hardware too. So I'm using an 8mm wrench right now to undo the other 2 bolts that I didn't get undone yet. So just remember, Flakers and Nuggets are metric hardware on the evaporators, metric, okay? So you need to go into your other set of tools sometimes for that. So I undid all 4 bolts, and this plate will just lift off. Also, I should mention, I removed the insulation that was sitting on top of this head as well. It just pulls right off, and I removed that insulation. So I'm going to take that plate out of the way. Now those 4 bolts, 1, 2, 3, 4, they're holding the breaker assembly in place. I shouldn't call that a breaker. That's just what I'm used to. We normally call it an extruder now, or on the unit, and that's the part that the ice gets forced through. Notice this flaker is a side discharge, okay? Side discharge on this flaker machine. Some of our evaporators are top discharge. The flaker is a side discharge on this particular one on this unit. So that got it nice and loose, and that's going to allow me to remove the auger. So I can lift this auger up out of the evaporator, and I'm just going to stand it there for a minute so you can see it. And it's got the top bearing and breaker assembly on the top of it. There I go again. Top bearing extruder assembly on the top of it right here. That has 1 bolt in the top. I'm just going to lean that towards you. And you undo that 1 bolt, and you can remove this bearing assembly and extruder as well. And you can replace it as an item on it as well. So what I like to do, just going to come down here a little bit, making it work, is I like to hold this bearing assembly, and I just kind of turn the auger in my hand to see if I can feel like any kind of notchy, sandpapery, gritty type feeling in that bearing that will tell me if the bearing's got damage or not to it, you know. So I'll just spin it and see if everything looks good. I'll also just look at these flights right here. I'm going to hold it still. So I'll look at the sides of these flights to see if I see any scraping or notching or anything like that, to see if the auger's been touching the side of the evaporator, which is not a good thing. So I got a top bearing assembly removed on this one that I just tested. So I'm going to go ahead and just lay this auger down for a minute. And the bottom of the auger has a water seal, which I'll show you in just a minute too, okay? Then I'm going to take the bottom bearing out. Oh, and now how I do this is there's 4 bolts in the bottom. They are 13 millimeters. I already took 3 of them out earlier, so you wouldn't have to sit there watching me just undo bolts, because it's not the most exciting thing to watch, or maybe it is, I don't know. So I'm going to take that last bolt out of the evaporator, and I'm going to lift this off the base. Now, if this was in the ice machine, you'd probably get a little bit of height on this base with the refrigeration tubing. You get a nice little gap here that you could take the bearing out if you wanted to. And it's in a bearing housing too to make it easier. What I'm going to do though is I'm going to put up my workbench so you can see it a little bit clearer, just for that reason. All right, let's take a look. There we go. That looks good. So now you can see the bearing here in the end of the evaporator, the lower bearing on that unit. And this one will just slide out. There it goes. It just slides right out. Now, maybe I'm thinking you're getting this out because maybe a water seal's been leaking and this is all rusted up. It's not just going to slide out like this for you, right? You're probably like, yeah, he makes that look easy, but it's probably just not going to slide out. Maybe it's not going to slide out for you. And then I'll test the bearing. So I'll kind of put my finger in the middle of the bearing part, and then I'll rotate the outer part of the bearing around, holding the inner, just to see if there's any like sandpapery or gritty feeling to it. This one's pretty smooth, actually. It's got a few dents in it because it's used here in my factory hands-on school. And I don't know, some student might have hit it with a hammer or something, which you know not to do on a bearing, okay? But let's just say it is seized in there. Let's say it's all rusty looking and it doesn't just slide out for you like that one. Then I can take the bearing housing out too. So to take the bearing housing out, all I do is I reach inside there. If the bearing's still in there, I'll go inside the bearing and then I'll hook around it and then I'll slide it towards the bottom of the evaporator. And you can see there's an O-ring holding this part in. And that way, if the bearing is seized in, you don't have to get a new evaporator. You could just get a new bearing and lower bearing housing that way. So that makes it a little bit easier to service than trying to force out a seized up bearing inside of a housing that's metal molded itself into that unit. All right, so I have the housing out that evaporator now, and I'm going to show you the water seal. So let's just take this housing right here that you can see, and I'll put the water seal in here. This water seal is a little bit scarred up, again, because we use it for training here in the factory, and it might have come out of a warranty machine too that came back for replacement. But you can see the bottom part of the water seal, this black material, and then the top part of the water seal, just going to get it in shot here. Here we go. Is that white material, and those two go together. So when the auger is actually in the evaporator, those are going to sit together like that. You see that? Yep. And then the lower black part is going to stay stationary, and the top white part is going to rotate on it, and that's what makes the water seal. I tell you, the nice thing about this is I've worked on a lot of flakers and nuggets in my time. Always learned the hard way too. The nice thing about this is there's no sealant in here. Like some of them you have to put silicone sealant on them, and if you pull the auger out, you better have a new water seal because you break the water seal and you need to install a new one if you ever pull the auger out. So it's very important that you carry that if you're working on a different kind of manufacturer, but not ours. This is a great setup, okay? This is a really nice setup. And I can take this off the auger too. It rides on a little spring, and I'll just rotate it down so you can see it. And now you can see the top part of the water seal, and I'll put it on the bottom part, and it'll ride in there just like that in the unit. Now you might say, water seal, why do we need a water seal? Well, here's what people forget. This whole evaporator barrel is filled up with water. This barrel right here, I know you can see it, is filled up with water, and then we have a shaft that has to come through the barrel and through the water into some kind of gearbox to turn the auger. So you have to have some kind of water seal holding that water back from going into the gear motor. If you ever open up a Flaker or Nugget, whoever's manufacturer, one day, and you see like a nice film of oil on the bottom of the unit and the bottom of the modular base of the unit, that means the oil is escaping the gearbox. That means oil is escaping the gearbox somehow. And the gearboxes are sealed, they're watertight, but what happens is when a water seal starts to fail, the water gets through the water seal and runs down the shaft of the auger, and then the water gets into the gearbox and it washes the oil out of the gearbox. Took me a long time to work this out, so maybe you won't have to go through all this hardness. And then once the water gets into the gearbox, it's going to force oil out of the gearbox eventually. Even a waterproof gearbox, it's going to force it out the shaft seal or something like that. So if you ever go up to a Flake and Nugget, and even if it's working and you're just doing a PM, and you see like a bunch of oil on the floor of it, on the bottom of it, like a film, that means that water seal is leaking water, and that's pushing the oil out of the gearbox on you. So another thing to check when you're working on this, just going to turn this auger around a little bit and have Will zoom in on a little bit. So we're going to want to take a look down the inside of this auger. I'm going to hold it nice and still for you. And we want to look for like any scoring or marks in there. Oh, this is a great shot. You can see those vertical lines in that evaporator. They're normal. They help the ice stick to the walls of the evaporator. A lot of people think that ice forms in this evaporator because it's so cold, and then it sticks to the auger and the auger pushes up. That's not how they work. What happens is ice sticks to the walls of this evaporator barrel, I call it, and then as it gets bigger, the auger pushes that ice off the walls and pushes it up to the top. Now, if the ice starts to fall off these walls in here that you see, then it's going to float around in the evaporator and it's going to land in the middle of the auger and it'll push it sideways. It'll put so much force on that auger that it'll push it sideways, and that'll cause bearing damage to the top bearing and the bottom bearing sometimes. So the reason I tell you this is if this gets a bunch of scale on the inside of it, the ice is not going to stick to it and it's going to fall off it and it's going to kind of float around in the evaporator, and that'll take your bearings out. So cleaning and keeping it descaled is extremely important on these type of flakers and nugget evaporators in the field. So I'm just going to put these parts out the way for now. Excuse me for a second here. So nice and easy to get apart, very service friendly. And just to review, we'll take a look on the screen at a couple of these pictures for you so you can kind of see it on the screen. I did it manually, which I always love to do because you saw it wasn't like a big headache to get it apart. I've rebuilt many Flaker's Nugget evaporators from many different manufacturers. This one is really nice to rebuild. You know, you're going to have problems if the seal goes and things are rusty. Yes, but compared to many, this one is very nice and easy to rebuild. So let's take a look at it. I'm going to remove the top insulation, just like I talked about. I'm going to pull that insulation off the top. I'm going to undo my 4 bolts. Then I'm going to lift my auger out of the evaporator. It's going to pull up out that evaporator. Oh, another tip. Do this when the evaporator is warm. If it's cold and you just turned it off and you drain the water out of the evaporator and you're pulling that apart and it's still cold, they don't come apart real well. So wait till it's warmed up to room temperature. Drain the evaporator. There's a little bleed off drain on it. I'll show you that in a second. And then you can take it apart when it's room temperature. So if you could see through my evaporator barrel, this is what it would look like on the left there. I got an auger, I got a top cutter bearing assembly, I got a lower bearing assembly, I got a lower water seal. These parts can all be ordered separately from your Manitowoc distributor on that unit. So that's the buildup of it. And you can see a nice picture of those little lines in there on that unit. Some units have a thrust and radial bearing on top, which is kind of cool. So when it comes to Flaker Nugget design, it's all about 2 things. It's about the bearings being really tough, and it's about the water seals being really tough. Those are the 2 things that make a good design. Some evaporators have 1 bearing on the bottom, that's it. Some have 1 on the top, that's it. This has 1 on the bottom, like I showed you, and then it has 2 bearings on the top. It has a thrust bearing to take up the up and down play of the movement of that auger as it makes ice. And then it has a radial bearing to take up the left and right play on it. So really strong ice machine. Here's my water seals, upper half, lower half of that water seal. By the way, that lower half, that material, that black material, it's kind of fragile. So don't drop your auger back down into the evaporator because you'll break that lower half. You want to just slowly place it down. I don't think you would drop it down in there, but don't drop it down. And if you ever try and hammer it out, that water seal is going to break as soon as you put any kind of pressure on it. I've broken them before by just dropping them on a concrete floor from, you know, up high off my step ladder. I've broken them that way too. All right, bearing and water seal retainer, lower bearing on that machine as well in that unit. All of this stuff that we talk about on these units too, as a review, it can be found in your technician handbook, all right? So I've got a technician handbook here. I've got an R model technician handbook, and then I've got an RFF RUNF technician handbook too. So this information can be found in these tech handbooks for you, picked up at your Manitowoc distributors. And then I also have, before I forget for later on, a countertop handbook as well. So I've got a countertop handbook on those machines too. All right, so we talked about reassembling and disassembling the Flaker. Now I'm going to take a look at a Nugget machine. So again, I'm going to come around, Going to pull this nugget apart so you can see it's a little bit different, but kind of the same on this machine. To pull it apart, again, it's going to be all metric tools. So I'm going to need metric tools to take this thing apart. So here's my nugget machine. You know what? Let's spin it around so you can see it better. This is actually an R&S 600, so a slightly bigger evaporator. We have 300s, but then we have 1200s as well that are much bigger as well. You can see this weird little thing on top. This is a top discharge. Ice comes out the top. You can see this little weird thing on top. This is the ice wiper that when the ice comes out these extrusions, it comes up into a top little cup, and this forces the ice down the chute as it goes down. So I'm going to take this apart a little. I'm going to take off this wiper, which just unscrews counterclockwise, obviously. So I'm going to take the wiper off, out the way, and then I have these Allen wrench bolts. Get my hands out the way. I have these Allen wrench bolts that go through it that, again, are metric. So if somebody's been working on it on a non-metric Allen set wrench, you're going to see sometimes they might be kind of rounded out a little bit. I took most of them out already, but I've still got 2 left in there that I'm going to take out. I'm going to try and keep my hands out the way so you can see. There you go. That looks good. You can see that coming out. So I'm going to take that one out the way too. And this will take my top plate off. So my top plate is going to come out. There it goes, my top plate. It's keyed to fit onto this cutter head or extruder on this evaporator. So I'm going to pull this out the way. Just going to put that out the way. And then I'm going to take this extruder out. So I can just wiggle it a little bit, and it will come off the auger shaft. See that extruder? I really like the way these are made. You can see it's got some sharp points to it as the nuggets get forced up. You could actually change the thickness of those blades, you could call them, that come up to change the size of the nuggets. As a manufacturer, you would never do it in the field, but you could do that. And this contains the bearing, okay? This is the top bearing extruder head assembly, and you can order that as a piece, so you don't have to force the bearings out of it. It comes as one assembly to try and make your life as a servicer much easier. Now I'm going to take the auger out, which is kind of heavy, and you can see it's kind of awkward to pull this shaft up on it. So a lot of times I'll bring my ice wiper back in here and just kind of screw it back into the shaft so I have something to grab onto on that unit. So I screwed it back to the shaft, and now I can just pull that auger up much easier and remove it from that evaporator, just like the other one. You can see at the bottom part of it, we've got the upper half of our water seal again on that auger assembly. Going to move this out the way. And then I'm going to undo the bottom bolts of my evaporator. Now, depending on the size of the evaporator, you may have to undo these lower bolts, which I'll show you on the screen, and turn the evaporator a little bit. Depends on how big it is to get to these bolts. But this one's not bad. I can get to all of these bolts nice and easy. And I got one left on here that I didn't take off, another 13mm bolt. Take that out the way. And then I should be able to lift this evaporator off. Remember, if it's in the unit, you're only going to lift it so high on that unit. Now this one, the bearing stayed on the bottom base, and I can just take that bearing out of there, okay? So the bearing stayed on the bottom base. But again, the same setup. This one's a little bit bigger, but it's still got a bearing assembly on it, and I've still got the black lower half of my water seal in here. So if I take this lower assembly out, you could see the bottom of that water seal. So I'm just gonna run this out of here. There we go. It's got an O-ring that holds it in place. And then you can see that bottom half of the lower bearing assembly, just like the other one. So very similar setup. Top is a little bit different because it's a top discharge, but you can see it in there. If things are seized up in there and you can't get this bearing out, I'm going to spin it over. It's okay. I'm just going to get it in camera. If you can't get this bearing out, the lower half, you can just take the whole assembly out and replace the bearing and the lower assembly in there. So let me just show you something. To put this bearing in, it always kind of fascinates me. It's such a tight fit. If you go at an angle, and remember, you might be doing this upside down. If you go at an angle, it's not going to go in. But if you go perfectly level on it, the bearing drops in on these units when you go perfectly level. So the bearings just drop right in on them when you go perfectly level. And then when you turn it upside down, they normally just fall right out of those units, okay? But if you kind of go at an angle, it'll get jammed. And then if you start, far be it from anyone to do this, if you start hammering it, you're going to be really in trouble. So they just drop nice and easily in. They have such a tight tolerance. So I'm going to put this stuff out the way. I'm going to leave that cutter head there. Oh, there we go. Get my hands dirty today. My goodness. Whatever next, right? And let's take a look on the screen at it. Thank you, Will. Let's take a look at the screen on it just to go over it. So when it's inside the ice machine, and we've got, you know, all the plastic stuff on it, everything like that. I'm going to show you removing that. So I took the insulation off, and then I removed the micro switch. This is a safety paddle switch. Basically, it's almost like a second bin switch. If the first bin switch fails and ice starts to back up into the chute, this paddle switch will hit ice, and then that'll turn the ice machine off. So it's almost like it's got two bin switches in case one of them fails closed. Then I'm going to remove this little ice wiper out of here. It will just unscrew. Once loose, you should be able to remove it by hand. So sometimes at first they're kind of tight, and I just give them like a little tap. I just tap them with, you know, like a soft hammer or something like that, like a rubber mallet, and then they loosen up, and then I just undo them by hand. Again, such a tight tolerance on there. They screw it in and out so nice and easy on those machines. I'm going to remove the bin thermostat bulb, and then I'm going to pop off the plastic that goes between the chute where the ice goes down into the bin and the top of that evaporator. So off comes that chute. I'm going to take that chute out the way, remove the whole ice chute, and then I'm going to take this ring of insulation off. It just lifts up too on that machine, on that ring of insulation. It just lifts right off too. So we're going to get that right off there on the insulation, and then we're going to undo my little metric bolts on the top of it, like you saw me do. And that'll lift the cutter head out the way. I can put the ice wiper back on again to get it loose, and I can lift up that evaporator. If you have to use a pry bar to break it loose, make sure you pull straight up to remove it. Normally they come right out, but again, if you're there, you're probably there because of a problem, like a seized bearing or a bunch of scale in it or something like that. So you have to be a little more careful with those units. We're going to lift that evaporator right out of that unit, and we're going to take it right out of there and pull it right out the top of there. We're going to lift that auger right out the top there, okay? So auger comes out, and again, you're looking for scale on the auger. You're looking for any dents in the side of those flights, anything like that. Top cutter head, again, I'm going to be looking for a nice, smooth bearing in there. I might put my finger in there, hold the inner race of the bearing, and turn the head or the bearing around on my finger and make sure it doesn't feel sandpapery or gritty. Looking for scale inside this evaporator. See these nice long grooves? It's really important they're clean. Otherwise, the ice won't stick to the sides of the evaporator. If there's a lot of scale on there, the ice won't stick to the sides of the barrel or the walls, and that's what you want. Instead, it'll form, and then it'll just kind of fall off and get into the middle of the auger, and I'll push that auger sideways, and then we'll get a lot of bearing problems on those units. Now, to get this one out, for the lower bearing, I had to rotate things a little bit for this big one. So I got my liquid line solenoid valve out the way, and I loosened my lower bolts. And you can see I'm using like a little ball joint Allen wrench here, which is really nice for these, because you can see it's difficult to go in at an angle sometimes. So I got all the tools here available to me. So I use like a little ball joint in there to get those loosened up. And then I can rotate it. And then I'm going to take out my rotation sensor, which I'll show you a little bit later on. And when I reinstall my rotation sensor, here's a great tip I never even knew. Pre-wind the wire. You know, again, I have to learn everything the hard way. So this rotation sensor screws in, and it's on a piece of wire. And if you just kind of put it in and start screwing it, the wire gets all kind of messed up and bundled up. So what a good idea is to pre-wind the wire the other way, and then when you screw it in, the wire straightens out. That's a good tip for anything. If you're working on a car or spark plug or anything, that's always a good tip to pre-wind the wire, so when you screw it back in, the wire straightens out the other way. So there's the speed sensor on it, on this machine. And once I've got that rotated and I can get to the bolts of the bottom of the foundation, I'm going to loosen those up. And you know, notice I'm doing it in the machine here, right? I didn't take it out and put it on a workbench. Refrigeration tube is still all connected up to this machine. There's a keyway on these evaporators, so you can't get them in wrong. So there's a little bolt on the top of it, and then there's a little hole in the foundation. So when it goes back together, you can't get it in the wrong way. That's another really smart idea, right? That we didn't have to do, but we just tried to make it easier for a service guy to make his life easier when he's putting things back together, that it all locks in. If you do have to force out a lower water seal or a bearing because it's stuck in there, maybe it's rusted in there, and you want to save it because you didn't order a new one, you know, get it out with a nylon removal tool. This is actually a nylon removal tool that we sell, that you can put in there and you can force it out nice and easy with no damage on it. Like I said, those lower halves of the water seals, they're pretty brittle and they will break if you hit them with any kind of hammer hard enough, or if you drop them from on a concrete floor from a high height, they'll break too on there as well. So here's the evaporator guts, just like the other one, all lined up. We got a lower water seal there riding. You can see the flights on that auger, nice and clean, no big dings in the side of it, and it's all looking in good shape on that machine. So just to review, we looked at a Nugget evaporator disassembly after the Flaker, upper bearing, water seals, lower bearings. Remember, two most important things in a Flaker Nugget build are bearings and water seal. Those are the things that will get you in trouble. And you gotta keep it clean, right? You gotta keep it clean. A scaled up evaporator will make that auger go sideways, and then you'll have a failure on your bearings. You know, I always used to say, if you've got a Cuba and you never clean it, one day it's going to go down, somebody's going to clean it, and you'll be back in business, hopefully. A Flaker Nugget, if you never clean it, evaporator's going to get scaled, the auger's going to go sideways, there's so much forces on it, and then it will destroy the bearings and the water seal. So if you never clean a Flaker Nugget and you end up replacing water seals and bearings, you know, that could cost you $1,500, $2,000 in parts for bearings and water seals. So it's very expensive if you don't clean it. So you have a PM customer that's got a Flaker Nugget, as long as you clean it at least once every 6 months with chemical cleaner, you should be in good shape. But if, you know, if they never clean it and it's been 6, 7 years and they call you and they say it's squealing like crazy all of a sudden, that's a good indication those bearings are gone, that it's tore up those bearings already. You might be able to clean it and it get back in shape, but if it's squealing really bad, it's probably too late for those bearings already. All right, so that was some of the mechanics of it. I hope you enjoyed that little breakdown. It's nice to do a little hands-on part on it. And we're going to take a look at some sequence of operation on them now, okay? We're going to be pretty quick with this. They don't have control boards in them. So it's kind of old school, where it's just one safety switch after another safety switch on the Flaker Nuggets. The countertops, they have control boards, but these don't. It's just you put electricity into them, and if they get through all the safety switches in a row, then the machine runs. But if one of those safety switches stays open, then we got a problem with it. And we got a problem with that unit. What's that? Yes, I have a rotation sensor right here. And I'll show you where it is on this machine in just a second on that unit. So this is my rotation sensor. Thanks for reminding me, Will, on that unit. And then I'll show you where it is on the machine as well. Great little item. I only got 3 wires coming out of it. That's it. That's it. But it makes sure that the speed of the evaporator is up to speed before it lets the compressor come on. Why would that make a difference? Well, if the evaporator is turning slow, that's a good indication there's something wrong with the bearing, or that there's still ice frozen in that evaporator somehow on that unit, and we don't want to run it slow and just force it against ice. I think what some people don't realize is that barrel is such a chunk of metal, such a big chunk of metal, just because the compressor goes off, it doesn't mean it stops freezing ice. There's a lot of residual refrigeration in there, and it still keeps freezing ice in the evaporator when that compressor goes off, because it stays cold for quite a, maybe 10 minutes. It could still freeze ice in there. All right, Flake and Nugget ice machines use an auger to remove the ice from the evaporator. Occasional squeaks are normal, especially when they're new and they're just kind of breaking themselves in. But if it's squeaking all the time and your customer's like, oh my gosh, what's going on? That is not normal on that machine. Oh, I'm sorry, a little bit quick there. So I got an on-off power switch on these little under counters. I throw the power switch, and like I said, I'm going to go through step by step my safety switches. So my bin thermostat has to be closed for the machine to run. My low temperature safety has to be closed. So I don't want to start that ice machine up with a cold evaporator because it might have ice frozen in it. And that would destroy the gear motor if it was a solid block of ice in that evaporator. So I'm going to go through a low temperature safety thermostat. Then I'm going to go through a low water safety switch. I don't want to run my evaporator with no water in it. That's going to cause damage. So I have a float safety switch in my float reservoir. And if it's not up, it says I got no water and I'm not going to be able to run. So I get through those. If I get through all those, then my gear motor is going to switch on, right? My gear motor is going to come on at that point, and my gear motor is going to run, and my contactor and compressor are going to pull in on that ice machine. My condenser fan motor is going to cycle on and off. It does have a fan cycle switch on it. Some Flakers and Nuggets don't have fan cycle switches on their condenser fan motors, but ours do. So just be aware of that. It does have a fan cycle switch on it, and it's normal for it to see it cycling on and off in a 70-degree, 75-degree room as it makes ice. That's pretty normal for it to cycle on and off like that. So I'm going to go through all my safety switches. If they're all closed, I'm going to run. Okay, so I got no safety limits, no service limits, no blinky lights, nothing like that. Just old school safety switches that have all got to be closed to let this thing run. So we're trying to protect our evaporator because it's costly and expensive on that unit. Now we're going to add a pressure switch. The 200 and the 350, they have a low pressure cutoff safety as well instead of a thermostat. So, as you know, if something's cold, the refrigerant pressure is going to be low. So we're going to use a low pressure switch to cut it off for safety if that's a safety concern right there in the machine. Instead of a thermostat, we're going to put a low pressure switch on that instead. So low pressure safety switch. Now we're going to step up a little bit, and we're going to look at a modular unit, which is not an undercounter. It sits on a bin or a soda dispenser. I don't know. And we're going to have some more safeties on it. By the way, hotel dispensers, I call them, they are not set up to dispense Nugget or Flake ice. They won't do it. Hotel dispensers, they're not going to dispense Nugget or Flaked ice on Manitowoc hotel dispensers, just so you know. So again, we're going to use an auger to move through there, and we want to protect those expensive bearings, that expensive gear motor and drive. So our safety switches are the protection. The more safety switches you can have for protection, the better. So as the machines get larger, you start to see more safety switches on it. So again, I got to have a bin thermostat closed for it to run. Then I've got a high pressure switch in line. Then I have a safety switch, which I talked about a little bit before. But there's a safety switch. So if the bin thermostat fails and ice starts to back up into the chute, like if If ice is backing up into the chute like a bad lunch, then you don't know what to do. If it's backing up in there and it gets into the evaporator, it's going to cause damage. So you don't want it to back up in the chute, right? You don't want to cause that damage in there. So we got a safety switch. Bin thermostat fails closed, doesn't go off when ice touches it, backs up into the chute. It goes off on this little paddle switch on the unit. So very important. Again, water safety switch. Very important we don't run this ice machine with no water in it. So we have a float safety switch in the water reservoir so it won't run. If all that looks good, we're going to start our 8-minute time delay on our compressor. So the auger comes on and it's moving, it's looking good. We're going to wait 8 minutes for our compressor to come on. Why do we wait 8 minutes? Maybe there's some residual ice in the evaporator still. Maybe it went off in full bin and then went back on really quick. So we want to make sure the evaporator clears out of all the ice that might be in there before we start more refrigeration. If you can't wait 8 minutes because you're a busy technician, there's this little jumper hanging out the side of the unit to jump it out. And I'll show you that in just a second when I show you the rotation sensor, okay? So if you can't wait, you're just going to jump it out. But that's a high voltage jumper, okay? So don't put a bent paper clip in there with your fingers. You're gonna light yourself right up. So you're going to jump it out if you don't want to go through that 8-minute bypass. We used to have a little tool to plug into that switch. We included it with the machine, but then people started leaving it just plugged in. They'd walk away from the machine and just leave it plugged in. So we don't supply that tool anymore. So you have to make up your own one. And the idea was, well, if they make up their own one, they're more likely to take it with them than just leave it plugged into the machine. All right, if I get through all that, get through my 8-minute safety, my compressor's going to come on. I'm going to start making ice. Fan's going to cycle on a pressure switch as it needs to on the head pressure of that ice machine, okay? So just, again, safety switch through safety switch. It's a little bigger, 600 now. Bigger machine, more safety switches. Well, I shouldn't say more safety switches, but slightly different safety switches. And the biggest one here is the rotation sensor. So as a reminder, power switch, bin thermostat, low pressure switch got to be closed, high pressure switch got to be closed, safety chute got to be closed. Then I get to look at my water, make sure I have water. If I have water, my gear motor comes on, no compressor yet. My gear motor's turning now, and then I go to my rotation sensor. So I'm going to have Will take a look at this rotation sensor for you on this ice machine behind me. Right, so this ice machine is plugged in, and I'm going to switch it on, and then you can take a look at this rotation sensor. So I'll just switch it on. And because of all my safety switches are closed, I know you can't hear it very well, but my gear motor and evaporator are now running. So I'm going to rotate this to the side just so, so you can see it. There you go. And you see I have this rotation sensor screwed in to the side of my evaporator. And it's blinking right now, and it's going to blink like this for 8 minutes, letting you know it's in its time delay. While I'm here on camera, you can also see this drain-off valve right here. Like if I wanted to pull this evaporator apart or clean it, I've got this little drain-off right here, so I can point this into my bucket, open it up, and drain my evaporator out nice and easy. Some evaporators in the industry, you just have to pull the bottom hose off the evaporator and kind of try and catch the water, and it goes everywhere. So this was an improvement for a service guy, so he could just drain it into a bucket or something and not have to deal with that on the machine. All right, so there's my rotation sensor blinking away. And when I get to 8 minutes, it's going to go solid yellow, and my compressor is going to stop. I'm going to rotate this ice machine to the front, but I'm going to keep Will's camera on it. And I'm going to pull out the bypass. So I can't pull it out too much, but I'm just going to hold it there and see if Will can zoom into it. Hanging out the side of my control box. Yep, you can see it. That's good. Hanging out the side of my control box is this bypass right here. If I wanted to bypass the 8-minute timer, And I'll show you, just stay zoomed in like that, what the bypass tool looked like that we used to supply. So here's the bypass timer on this machine, and all I have to do is plug it in here. And I don't know if you can hear that, but my compressor came on. And now I'll rotate you back to the rotation sensor. And yeah, you can see it. You can see it's gone to a solid yellow light on that machine now. So now it's gone to a solid yellow light. I'm going to rotate this back, and I'll just switch this ice machine off for now so you can hear me. But you saw me bypass it, and we can go back to the main screen when Will's ready. So my rotation sensor. Now, rotation sensor, if something goes wrong with this rotation sensor, if it's not up to speed, it will go red on you, okay? So there it goes red. So now it's flashing red. This means that my auger wasn't turning up to speed. 10 minutes, I'm sorry, was turning up to speed, and it started flashing red on me. So it says, for some reason, my auger's not turning fast enough, and I'm gonna look out, and I'm gonna start blinking red on you. So it will try again afterwards. It'll say maybe it was just a freak thing or something. So I'll try again. Now, after it's tried 8 consecutive times, due to a speed fall, it'll quit trying and it'll just be sitting there flashing. So more than likely, when you get there and you walk up to the machine and you see this red light flashing on the speed sensor, it means that auger was turning too slow. Could be a bearing, could be scale, could be either of those things making it turn too slow. And actually, they will flash if the auger was turning too fast as well, which is very unlikely, but they will flash if they're turning too fast. In the technician handbook, it will tell you about that rotation sensor, and it'll tell you the revs per minute it's looking for. We can help you with that with tech support, but basically, if it's flashing, it's turning too slow. Maybe it's scaled up, maybe it's got bearing problems on it already, and it's too late for it. So 4 revs per minute and lower de-energizes the compressor for a slow speed. 13 revs or more will de-energize the compressor for high speed. So as long as we're between 4 and 13, we should be okay. Normal revs per minute is 9 to 10. So you could, there's a little hole in the side of it. You could put a mark on there, a little bit of paint or a permanent marker, and you could start your stopwatch for a minute and see how many times it rotates. It should be between 9 and 10 revs per minute is normal on that machine. So if you're just like, maybe it's just a rotation sensor that's misfunctioning, you could check the rotation on it. So really important that you understand the rotation sensor and its function. You know, could it fail? Anything could fail, of course. So if you've got one that keeps locking out and it is rotating at 9 to 10 revs per minute, you could have a rotation sensor problem. Unlikely, I rarely see rotation sensor problems on these machines. It's a good, reliable little unit, and it uses sensing to see where it's moving on the rotation. It's not like a tachometer that shines a light. It's more like a rotation sensor. Yeah, Hall effect switch. Thank you, Will. That's what I was trying to see. Like, you know, like a burglar alarm when you move your hand and it picks up motion. It's more like that than like something that shines a light off something reflective to see how many times it sees it on that machine. All right, troubleshooting. If it's flashing, we're getting problems. We can bypass the time delay so you don't have to wait on that machine, and we can go through the compressor on that and the fan cycling switch too. All right, make sure everything's working. Go through your wiring diagram step by step. In the real world, when I would come up to one of these, I'd basically turn it on, nothing would happen, and I'd be like, what's going on? I don't have any safety limits to look at. So then I would have to go through the safety switches one by one and see if they were open or closed. If any of those safety switches there are open, machine's not going to run, right? So if your rotation sensor is flashing, that means all those safety switches were closed, because the rotation sensor is the last in the line on that unit. Probably the most likely is you've got no water to the machine and the water sensor float is down, okay? All right, toggle switch on a 1200. 1200 a little bit bigger. Really the only difference with a 1200 or a 1,000-pound ice machine is you have a liquid line solenoid valve in it. It still has a rotation sensor on it. Really, that's the only difference. And the liquid line solenoid valve is to prevent rotation on it. It's just there to say, I'm sorry, the liquid line sensor is to prevent migration on it. So it's just to say, when I turn my ice machine off, this is such a big evaporator. I don't want my refrigerant just to float around wherever it wants to go in the system and then start up later. I'm gonna close that liquid line solenoid valve, and I'm gonna kind of trap my refrigerant from floating around in my system when it's off, because it's a much bigger system. So that liquid line solenoid valve is in there, all right? All right, 2200 or a 2000 ice machine. This basically has two 1200 evaporators in it. Two 1200 evaporators in it. So it's got all the same safety switches on it, but it has two rotation sensors and two chute sensors on it for safety as well on each evaporator on that machine. So we got two rotation sensors on it. I'm sorry, a little bit fast on my clicking there. Two rotation sensors on it and two chute sensors on it, and a liquid line solenoid valve to keep it pumped down as well on this ice machine. So you can see there is two relays in there, one for each auger, just one compressor on this ice machine too. A lot of people will ask me, they'll say, hey, if one evaporator's got a bad bearing, can I just jump it out and run just the other evaporator? Well, you can, because this only has one compressor, and you cannot do that because this has only one compressor in it, and it would be overfeeding that one evaporator. It's designed in a sized way to feed both those evaporators. That's a common question I get. Bin thermostat is located on the left chute of this machine to make sure everything's in good shape, all right? So here we are, two evaporators on my one compressor system. Two evaporators on my one compressor system, two gear motors on that unit, uses one TXV on the top of that system. You'd see a big ice machine like this in a seafood store, and sometimes I'd see them on top of walk-ins, raining down flaked ice or nugget ice into a big walk-in, and they would shovel it and they would pack fish with it, and sometimes they'd ship it all around the globe on those units, all right? You can buy this 2200 ice machine in remote condenser version. So we can put the compressor out on the roof to get the noise. It's a big unit. It makes a lot of noise with that big compressor, but we can get the noise out of there if we want to by putting it on a remote condenser unit. You know, I'm always tempted to call it CVD, but CVD stands for cool vapor defrost. There's no defrost on a flaker, so I can't really call it a CVD, but it's the same scenario where the compressor's outdoors, the condenser's outdoors on this ice machine. And it's got its safety switches. We got to get through all those safety switches for this to run on that unit out there on the unit. So basically, bigger the ice machine, bigger the Flaker or Nugget, the more safeties it gets. So little tiny ones maybe only have a few safeties. Big machines, they're going to have more and more safeties to protect those bearings and those expensive augers and evaporators in those machines. We got to protect them. People don't clean these machines. They scale up. The auger wants to go sideways and destroy those bearings. Before those bearings get destroyed, we're going to put safety switches in there to try and protect them on those units, okay? So safety switches on there. The last one we're going to look at today is the countertop CNF 201, 202 ice machine. So this is a Nugget ice machine, and it still has the same kind of evaporator in it as we just looked at, but it's going to be contained in a unit that sits on a countertop. Blows air out the top on the condenser. Ejects that air out the top of the condenser. We have a selector switch on there to select if you want water or ice. We have a dispense chute on the bottom there. We have an on-off switch just underneath there on the unit. There's also a clean switch there as well on that on-off switch. Dispensing lever, drip tray, condenser air in. So it comes in on the bottom right, blows out the top of that unit. So here it is without the panels on. You can see there's an air filter in front of that condenser right now, just a materialed air filter on that machine. Float assembly, gear motor, control box where my control board is located, on-off switch, condenser air filter, drip tray, touchless dispensing on this one. So you can get this in manual dispensing with a lever on it where you push your cup on it, or you can get it in touchless dispensing as well. Dispensing chute, dispensing selector, ice storage bin, data plate. This comes in two flavors. We either have a 20-pound bin, that white bin there, that holds 20 pounds of ice, or a 12-pound bin that holds 12 pounds of ice. Everything else is pretty much the same. Just we have one that's taller, one that's shorter, one that can hold more ice in the dispensing bin. Same compressors, same evaporator, same auger, everything the same. We just have a slightly larger bin on those machines. All right, let's take a look at the top. Automatic expansion valve. So that's kind of weird, right? And a thermostatic expansion valve you've heard of. But an automatic expansion valve is just an expansion valve that doesn't move. It sounds fancy, but it's just a valve that doesn't move, right? It looks like a evaporator pressure regulator or a crankcase pressure regulator, or it just doesn't move, it just regulates. So it's got a little hole in there like an expansion valve, but it just doesn't make that hole bigger or smaller, because flakers and nuggets like this nugget, they don't have a wide range of power on them. They just make ice at the same rate all the time. They don't go through these big changes in heat that a Cuba does. Float valve assembly, data plate, Hall effect switch, sensing the ice coming down the ice chute, and a damper door in there that senses it. We have an ice wiper up top there too, just like the other one. It's just a little smaller and a little bit of a different material, okay? This does have a control board. Let me get some water here. I know we're at a time limit. I've got about 5 to 10 minutes to go, okay? That's about it. I knew this would run over just a little bit, but that's fine. I'm here all day. No. So here's my control board. Inputs on that control board. We've got a switch to tell it if it wants ice, off, or clean cycle. And then we got some weird Hall effect switches, right? And we'll take a look at those as well. This is where my Hall effect switch is. It's basically a positional switch, and it's 2 positions. There's Hall effect switch 1 and Hall effect switch 2. You could think of it like a magnetic bin switch. It's really not. That has 2 different positions. There's one position it senses, and then there's a second position it senses. It senses when it's halfway up, and it senses when it's all the way up on there. There's a float switch. I don't want to run this machine with no water in it. That's bad news for my Nugget ice machine. It's going to cause damage. And there I've got my on-off clean switch on that unit. Outputs. So I've got some outputs on this machine. You can see I got 3 relays, so I must have 3 outputs. Dump valve to drain the evaporator, a gear motor to turn the auger, and a compressor contactor coil to run my compressor on those outputs. Here's my little off-on clean switch tucked underneath on this evaporator. You know, something else I've noticed, be careful, because I've seen cleaners come in and they'll be cleaning under there and the switch isn't in an obvious place, and they'll switch it to the off position sometimes and not realize what's going on. And people don't realize there's a switch just tucked under that ledge right there, so look out for that. Prior to startup, 15 minutes prior to startup, delay period must expire. 15 minutes, oh my gosh, I haven't got that long to wait. I'm a technician, I can't wait 15 minutes. This is to make sure there's no ice in the evaporator before you start it up. So you can bypass it. I'll show you that too. So HES1, this is when the damper is all the way down. HES1 light will be off, telling you it's okay. So this is my bin switch right here. The damper in the chute is my bin switch. When the damper gets stuck open, I turn off in full bin. The HES1 and HES2 positions on this damper. When the damper's halfway up, HES1 light goes out. When the damper's all the way up to the top, HES2 light goes out. So HES2 is your full bin. HES1 makes sure that you're making ice, that nuggets are coming down the chute and then moving that damper around. Again, we're going to use metal safe ice machine cleaner because this is a nugget to clean this ice machine. So to get this unit running, my time delay has to be expired, my water safety has to be in good shape, and my ice chute damper must be in the down position to tell me it's not on a full bin on that machine. So here's my water float, sensing water in there. I'm good to go. I can see I got water in there, and then I'm going to make ice and go through my startup. This one's kind of unusual because it does have a dump valve in it. That's kind of cool though, because I can drain all that water out the evaporator and start off with a fresh batch of water in my evaporator. And that helps to keep my evaporator nice and clean and purge all the minerals out of it. Think about it like this. If you've got debris in your water, scale and little bits of debris, where's it going to go in the evaporator, right? It's going to sink and it's going to sit on that water sill, you know, every time. So the fact that we can drain this evaporator out, that's a pretty cool thing to have a dump valve in that evaporator on there. So 30-second dump cycle, and the machine was off for more than 4 hours. We've done various updates on this board, but today's board looks like this. There's a 15-minute time delay. There's a 30-second water purge on this ice machine, and you can bypass the delay by pressing that little button. So if you're a technician and it's in the delay and the lights are going up and down, you can press that button. It'll bypass the delay so you don't have to wait. Refrigeration system, nothing to it. Just a real simple automatic expansion valve, an evaporator, a condenser, dryer in there, compressor on that ice machine with a heat exchanger. Real easy automatic expansion valve system. So we looked at a little countertop, only available in air-cooled, no water-cooled versions, only 2 versions of it. Basically, the only difference is the size of the container that holds the ice in that ice machine. All right, looking good. We're almost at the end now. Just as a reminder, we do have additional training. Hang on, let's get some water. You can go on our website and take free classes on our website, which is crazy. Our online training is completely free. I've been to some colleges lately. My daughter's in college. Online training, not free typically, but these are all free courses on our website. So if somebody new at your company, sit them down and do them. We are continuing with virtual training this year. We don't have in-person classes because of COVID. Unfortunately, I don't like it. You don't like it. So we have a setup with virtual training. Check with your distributor where they'll do, like you used to go to a hotel and your Manitowoc guy would show up and they'd take you through your training. But we have it set up virtually now. So check with your distributor and you'll get a packet of books and the usual stuff, but you'll be able to do it at your computer or in a meeting room at your office or something like that. Because of COVID, we can't do face-to-face. So our virtual training is going on right now. In fact, there's one today going on that I know of. Thursday this week is another webcast for Cool Air ice machines. So if you don't know anything about Cool Air ice machines compared to Manitowoc, come back, see me on Thursday. I would love to have you here on that unit. And then next month, our regular Manitowoc webcast is on troubleshooting. So May, we're going into the summer. We're starting to hit the heat. Most ice machines break down when it gets hot. So we want to do a troubleshooting webcast in May going into the summer for you. So that's going to bring me to the end. Thank you from Manitowoc. And you'll be able to take this quiz that Will's going to put up. He'll put it in the chat section of the Q&A if you want to click on that link on your computer. Or you can just scan the QR code here on the phone, on your phone, and it'll take you straight to the quiz. Go ahead if you have time. Get over there, do that quiz, get your certificate. It doesn't take long. It reinforces what you learned. You can actually do the quiz as many times as you want. If you get, if you get one wrong, you can go back and do it again. It's not a pass and fail criteria, but go ahead and do it. So that's it from me. Jonathan here at Manitowoc Ice. I hope you come back to our next webcast. I hope to see you again. Be safe out there going into the summer season, and I look forward to seeing you all next time again soon. Thank you.